This is a very interesting thinking problem, and I have seen this problem many times in the test paper. Question 32. A ball dropped from a height of 5 meters bounces to a height of 80% of its previous maximum height after each bounce. Complete a table to determine the height of the ball after fourth bounce. So we have to make table of values and then find out what is the value after fourth bounce. And part B is develop algebraically an exponential model for the situation. And C is determine the 10th maximum height of the ball. Now I'd like you to think over this problem, copy it down and try to solve it. Okay, first try to make a sketch that is going to help you solve this problem. Correct? Once you've done your work, whatever you can, and once you got your answer, then look into the video for the solution. Okay, now if I'm here to solve this, then I would like to first sketch a graph, right? Or rather a figure which will reflect what is going to happen here. So we say a ball is being dropped, and so let me just make it think like this. So we have a ball which is getting dropped from, let us say, some level, and that level is 5 meters, right? So it goes here down, right? So when it goes down, it just bounces back and then goes back and then do 80% and then comes back. And then again it just bounces back and then come back. So this, I'm trying to show the time here, right? But ball is bouncing at the same place. You understand? Ball is bouncing at the same place, but I'm showing that every time, what time is flying. So here I have time here just to separate this out. Otherwise things will be overlapping and it's very difficult for me to show you here, right? So with time we see the ball is shown here. So it goes to different heights, and like that it's like decreasing every time, correct? Now let us say that this is the height of the ball after each bounce, and that at 0 we just left the ball from 5 feet. Is that okay? So 5 is the position when we left. Strictly speaking, the ball is just bouncing here, right? Do you understand? And I'm trying to show you, stretch that out because of the time, to show you how it will be after every second passing by, right? Okay, now once it bounces back, we say it bounces to a level which is 80% of 5. So here we have a value which will be 5 times 0.8. Is it okay? That will be my first bounce value, right? So let me write this value here and show it with an arrow, kind of like that is the one, right? The second bounce will be 80% of this value. So I can write this as 5 times 0.8 times 0.8. Do you see that? So that is my second bounce, right? So you will see that I actually multiplied by 0.8 times 0.8. So 0.8 squared, you see, and that's the second bounce. So I'm calling here this as my first bounce, right? This is my first bounce, and this is my second bounce. So after second bounce goes to this, this is my third bounce, fourth, and so on, correct? Now here it will be 5 times, I can write 0.8 to the power of 3, correct? Because I've already multiplied by 2 and I'm going to multiply by 3. And after fourth bounce, I get value as 5 into 0.8 to the power of 4. Is that okay? So we see that there is an exponential decay, and it is by a factor of 0.8, right? So we can write this function as height h of t for the ball. I should have written number of times. Let t be the number of times it hit the ground, okay? And h be the height of the ball after it bounces back, correct? So initial height is 5, so I'll write 5 there, and my factor by which I'm multiplying is 0.8 and times to the power of t. Do you understand? Where t is number of bounces, where t is times the ball bounces, okay? T is the time times the number ball bounces, right? Not the time t, okay? t is the times. So these are times. So I've just changed my definition here and writing t as times it bounces, right? Correct. And just to show you for clarity, I've stretched it out. Actually, the bouncing will be done only at one point, right? Okay, so we have this, and well, completing the table of values, I can always make a table of values here, writing t, calculating these values and putting them there. Well, I'm leaving that for you now. It was a quiz for you, and I'm giving you hints how to solve. So at t equals to 0, so you can make a table of values. For example, like this, correct? So we can say here that this is the number of times it bounces and this is the height after every bounce, right? So if we have kind of like this, so we have, let's say, initial value. So let me just write 0 as the initial value where it is 5, correct? After one bounce, it is 5 into 0.8. So we'll write, well, say 5 into 0.8 equals to 4, correct? And then second bounce, it again gets multiplied by 0.8. So we'll say 0.8, right? And gets 3.5, which could be written as 3.20. So we say 3.2. And after the third bounce, again I will multiply by 0.8 and get the answer as 2.56. And after the fourth bounce, I'll again multiply by 0.8 and get answer as 2.048. Correct? Now determine the 10th maximum height. For 10th maximum height, what should I do? So we say h of 10 equals to 5 times 0.8 to the power of 10. So we say 5 and within brackets 0.8 to the power of 10, correct? Which gives me 0.5368. Correct? Maximum height of the ball in meters. So well, we can write 54 centimeters. So which I can say is approximately 54 centimeters. Does make sense? So these heights are given in meters, okay? And finally, part D, part C, we get height after 10th bounce. Maximum height can be 54 centimeter. Correct? I hope you enjoyed the whole experience of going through this quiz. We still have few more questions to come, but we have covered all types of questions: the knowledge-based questions, communication questions, application questions, and thinking problems, right? So we have further to go with few more, but take a break, think about what we have done, and get ready for the next question. Thank you.